Okay, so we're going to get started. Our next talk is on extended Kubernetes with CRDs and operators. I know Kubernetes is a very hot topic and interest from a lot of people in this audience. We have Chris Hine, who is coming from AWS. He's a senior developer advocate in Kubernetes EKS at AWS. So we're going to hear it from the horse's mouth and shoot all the questions you have.
Please do.
Welcome, Chris.
Cool. Can you hear me? Great. Thank you for the introduction. So I'm Chris Hine. I'm a developer advocate at AWS. I spend most of my time in Kubernetes. I also support EKS as a managed solution, but I stay mostly in the open source projects. I contribute to things around Kubernetes like the SIG projects. As well, I just recently, as of like last week, I think, got accepted as a CNCF ambassador, so I'm super excited about that. If you want to reach out and talk to me, that's my email address. I'm on Twitter at Christopher Hine, and I'm on GitHub at Christopher Hine if you want to check out any of my ridiculous projects. Today, I'm basically going to be talking about extending Kubernetes with CRDs and operators and controllers. I've been fighting this kind of terminology between operators and controllers because they basically are the same thing. I have a definition later though. Before I get started, raise your hand if you're actually deploying Kubernetes currently. How about in production? Okay, keep your hands up though. So, how many of you are using operators currently? 1, 2. Okay, fantastic. How many know what operators are? Okay. How about CRDs? All new topics. Fantastic. I start from the ground up, so I hope everybody can get on the same page then. So, first off, I always like to start with this. What is Kubernetes? And I'm not going to answer this. I want everybody else to answer this. Tell me what you think Kubernetes is. Container management. Anything else? Substrate. Okay. Very cool. So basically, this is how I define Kubernetes. Sort of. I'll change this in 1 second. But I define it as an open source container management platform. With that, it helps you run containers at scale. And lastly, it gives you primitives and building blocks for building modern cloud-native applications. If everybody's talking about cloud-native applications, I'm not going to. I'm trying to talk about operators. They're more fun. But I've been changing this recently in the way that I've been talking about it, because I believe it's more than just an open source container management platform. I've actually been crossing out container now and just calling it an open source management platform. That's really what it is. Under the hood, it can be dialed down into something incredibly simple. Hopefully. Maybe you won't agree. This is what I think it is. It's just an API. That's all Kubernetes is. Behind the scenes, if you actually dive into the components that make Kubernetes work, this is the one that is the most important. The API server. It's what everybody's gotten around. It's a specification that everybody agrees with. And it's a designed API that allows you to extend to anything you want. That's why I call it not just a container management platform. So, how many people have actually gone and done things like pass-in-v7, for example, into kubectl? Also, I call it kubectl. Wait, one hand went up for like a second? Nobody's actually looked at what the requests are from kubectl? Fantastic, I'll show you. Looks like this. So, behind the scenes, this is just an API. That's all you're interfacing with. Kubectl is just a client for it. It's very simple. I assume, raise your hand if you actually build like web applications or APIs, JSON APIs. Fantastic. Does this look really similar? Yeah? Super easy. So, here's how it breaks down. You basically have iExchange API server with the host name, but we have /API/v1/namespaces/ the namespace that you're passing into, and the resource that you want. Very basic, right? JSON API. Pass in some headers. Oh, I want to accept JSON. Fantastic. And I'm going to pass in a version into my API because that's how we do our versioning in Kubernetes. We version every single object independently. And then we have the actual API domain that goes along with it. We'll pass in the actual user agent so we can actually see where these requests are coming from, if they come from things like operators or controllers within the system. And then behind the scenes, we basically have our response body that comes back. This is just another Kubernetes object as well that gets returned back. And you've seen these before because they have a kind, an API version, a metadata, and then a spec. In this response, it would be an items key. Very, very, very simple. Just JSON. That scare anybody? Are you gonna go home and like traverse the API now and see what everything's doing? Makes me super excited that it's so simple behind the scenes. So if you take that to one layer deeper, and you said run kubectl proxy, this will expose on your local machine, localhost 8001, for example. You can go to that, and you'll see this. The ... has a lot more APIs behind the scenes, but it's everything that Kubernetes exposes is shown there. Now, what are these? Can somebody tell me what each one of those, for example, what is under admission registration? Anybody know? What? You are absolutely correct. There's a controller behind the scenes. So, can somebody define what a controller is? No? No? Can you define what a controller is?
It reacts to things.
Okay, it reacts to things. That's a very good definition. Basically, behind the scenes, this is actually a base resource. It's an endpoint, and that endpoint is exposing a single type, or multiple types. This one goes under v1 beta 1, and underneath v1 beta 1. For admission registration, we have things like the admission review objects. And that's a component of Kubernetes that gets passed through to things. In that exact example, it gets passed from the API server into any admission webhooks so that you can actually see, or so that you can validate or mutate those requests. Does this make sense so far? Have I lost anybody? Should talk a little louder. There we go. Cool. So, what all those do is they expose Kubernetes objects. And Kubernetes objects, you can think of as a record of intent. Does anybody know what I mean by a record of intent?
No.
All right. So Kubernetes is based off of the controller pattern. So everything is asynchronous. So when you actually pass something into Kubernetes, into the API server, you're actually saying, store this object. Don't do anything with it, just store the object. So it's realistically a pass-through to etcd. That's really all you're doing. In the API server, there's a couple other pieces. It passes through the admission controllers, the dynamic ones, as well as the compiled ones, as well as it goes through an auth lifecycle to check to see if it's auth based on certificates or webhooks or tokens or static files or anything like that. And the pipeline's pretty basic. But then at the end, it just stores it in etcd. So how does Kubernetes work from there then? So, actually I guess I should go through the rest of these bullets, because it persists entities, again stores that all in etcd, and it marshals the desired state of your cluster. That's really, basically, all the same bullets. And the examples of these resources are things like pods, services, ingress, network policy. Can anybody call out anything that's not on that list while I take a drink of water? What?
Jobs.
Jobs. Jobs aren't on that. How about some ones that aren't so common? CSRs? Maybe? Certificate signer requests?
Service account.
Service account? Yep, absolutely. Do I have namespace on there? No, namespace on there. Cool. So those are all very basic objects that are exposed, and those are exposed through these exact APIs behind the scenes. And if we go back one more slide, the end of this would be whatever those resources are. The API is pretty simple. It's a pass-through. It stores data. I really like this because it makes me excited for the future where the API server and Kubernetes itself doesn't have those base objects in it. We will eventually get there. Tim Hawken had a lightning talk at KubeCon last year in Seattle about this. The Kubernetes API server and everything that goes along with it as a base construct will eventually be removed, and all of these things will be considered add-ons that you build into your clusters, which is pretty exciting. If we get to the point where there's actually only admission controllers and the auth lifecycle, and then CRDs, custom resource definitions, which I'll get into later, it's going to be really cool because you can extend this to anything you want. Kubernetes isn't container management at all at that point. It's a management platform. So, now that you have all these entities, what can you actually do with it? Since it's an evented system, how do they actually work? They all work based on the control loop. And the control loop is basically a concept that kind of comes out of robotics, where you have a state, you get some notification about something, so feedback, and you reconcile. So Kubernetes in itself has the scheduler, has the cloud controller manager, kube proxy, the kubelet. All those things basically are running this exact same loop. And even internally, there's about, I think there's about 50 plus controllers for every single one of those resources that gets exposed. So a pod in itself runs this same exact control loop. And that's all it's doing, is it's saying, I have a desired state, etcd, it has something in it, it says, I'm supposed to have a pod. It checks to see if the system has that pod somewhere deployed, in the scheduler, for example. And it says, I don't have that, where can I put it? And in that reconciliation loop, for example, from the scheduler, it says, hey, put it on this node. And then over here in the system, you have kubelet saying, oh, hey, I got a notification that says I'm supposed to schedule something. Awesome, I've got resources, let me just put it on the Docker daemon. And then it schedules it. So a completely evented system behind the scenes, which is, in my opinion, just what makes me so excited about Kubernetes. It's such a neat distributed system behind the scenes. Anybody have any questions so far? No? Cool. That either means that I'm doing a good job or nobody wants to talk. So, what do we get out of all this complexity? Because it is really complex. When you really think about it, imagine just building that system by yourself. You're like, oh, I'm going to build this in Node, and oh, now I have all these promises everywhere, and it's crazy, and I don't know how to handle this. Well, we get some really neat things. We get immutable infrastructure as well as immutable containers out of it. We get declarative design. Everything's YAML. You write what gets stored in etcd. We add a couple keys, but not much. And because of the system and how it's all built, everything is self-healing. You kill the pod, it boots up somewhere else, gets rescheduled. In the world of CRDs and things like that, you destroy whatever resource it's created, it goes and recreates it. And these are all just really fundamental things to the Kubernetes system in itself. Any questions? Cool. So how does it all connect? I think I explained that a little bit already. I don't remember what I did. Oh yeah. It all connects with controllers. And this is a very small subset of the controllers that are in the Kubernetes system. I basically searched the Kubernetes on GitHub for, I forgot what I actually searched to basically pull up this list. But these are individual controllers. There's a lot more that go along with it, but you might recognize some of those. Cron job, for example. Replica set, replication controller, resource quota. All those things that you have built and deployed into your clusters, those are all backed by these controllers. Again, controller. Really powerful. So how do we get on to what I care most about, which is extending Kubernetes? So how do we extend Kubernetes? Extending Kubernetes, because it's built to be highly configurable and uses that control loop pattern, it automatically exposes a handful of things that allow you to extend Kubernetes. Things like storage. There's now a project called CSI, Container Storage Initiative, which a bunch of people from Mesosphere and Google got together and wrote the specification for how to do storage across container orchestrators. We added support for that in Kubernetes, and now you can extend it and say, for example, AWS, we just released at reInvent last year a Lustre file system, a managed Lustre file system for you. So for machine learning, you can basically use this system, and we built a CSI driver that you deploy in your cluster, and if you deploy a persistent or a storage class that is supposed to use that persistent volume behind the scenes, and you deploy a claim for the persistent volume, you immediately get a Lustre file system. You don't have to go into AWS into the console and actually deploy it. You're just using YAML, and it's declarative. And now you've extended Kubernetes to use these external components. Devices, that's like the NVIDIA drivers. all that stuff is now as interfaces that you can expose. How many people have worked with CNIs before? Container Network Interface. 1. I know 2. There's not raising hand. So network plugins. So the Container Network Interface is another way of doing that. Aggregate API servers. Does anybody deploy Service Catalog? Or any of those kind of things? Any aggregate API servers? All right. So that's a different way of exposing or of extending Kubernetes. And what it does is it allows you to take the Kubernetes API server and extend it to a fully custom subset. So if you wanted an API, for example, Service Catalog does this. And what Service Catalog does is it exposes an API that allows you to manage abstract data behind the scenes. So you have, for example, service classes and service instances, and those represent anything in the world, anything you want in the world. And you basically can expose this API. Behind the scenes, you implement brokers, which implement this API, and anytime you deploy a service instance into that aggregate API server, it does something behind the scenes, uses that control loop. I'm going to talk about an easier way, using CRDs and operators. Here's a quick link to a list of operators, which isn't important yet. I don't know why I put it on the slide, but it isn't important yet because you don't know exactly how powerful these things are yet. So, custom resource definitions. This is where, in my opinion, Kubernetes gets incredibly interesting. I currently, and I'll show this at the end of this demo, I'm a core maintainer and creator of a project called the AWS Service Operator, which is basically a project that sits in your cluster, listens for custom resource definitions that look like Kubernetes objects, but actually model AWS resources, and deploys them for you. So like what I was telling you about the Lustre file system and CSI, I've done that for any subset of AWS resources. Currently it supports about 9 resources, and I have work on, basically, I'm knee deep in getting it so that it supports the full catalog of AWS resources. So you'd be able to deploy anything from Kubernetes that AWS supports. So what is a custom resource definition? If you go back to, or if I was to go back to that slide about the API server, it exposes new endpoints on that API server. So it goes in, and when you store that, in etcd, you have a YAML file that says deploy a kind of custom resource definition. I want to specify it at a specific name, and any short names, what's the plural name, and behind the scenes, it goes and exposes new endpoints for you. So that kubectl can then say, hey, create this thing, and it will just store it. It'll just pass it directly into etcd, and you can build things that take action on those resources. You basically can define with a pod or without one. The pod in this instance would be what you're actually deploying as the operator that goes and mutates those things, or does some action based on that. It uses YAML to basically create them. And there's built-in mechanisms to extend it like we have with things like pods, where you could do, or replica sets where you could do scale, for example, on that resource. So you have status, scale, I think that's it for now. You also have validation built into it, where you can define these things in YAML that I'm going to put this into etcd. When you get this resource, make sure it matches this specific specification. Anybody have any questions? Yeah?
It's a good use case for CRD without pod. Good example.
Yeah, that's a great question. So a good use case for a CRD without a pod. The only one that I can think of, which technically has a pod behind it, but it's a little bit abstracted away, is Arc or Valero, I think, from now VMware, what was Heptio. Basically, they have a backup solution, and what they did to make all of that work is they would store state of the system in a CRD, and they would just inject it into the CRD and have it there, and then do a backup of that CRD into like an S3 bucket, for example, so that you could recover to another cluster. So that kind of uses a pod still, but it's more of a way of just storing random data instead of putting it in like a config map, for example. Any other questions before I move on and show you what a CRD looks like?
So normally Kubernetes provides sufficient for now to be replicated. But like he asked, what is the use case, right? Still trying to think what's the second that go for CRD. Okay, I need to create now. Can you explain what use case?
Yeah, I'll show you. I'll actually show you, and I'll demo 2 use cases. So, first off, this is straight out of Kubernetes documentation. This isn't the demo that we're going to do or that I'm going to show you, but this is the straight out of Kubernetes documentation. They have a custom resource definition. In there, you specify the name, and the name actually represents the group that goes along with it. You'll notice that group is right here. Group also shows up there. And then it requires you to specify the plural name as the first key. So very similar to a standard API version that you'd have in there. You can pass in the version that you want. This is actually now a an array. So you can actually have multiple versions, and you can store and present different versions all at the same time. I probably won't go into that because it's a little bit deeper. And then you have a scope. So scope in Kubernetes. Can anybody tell me what that would mean? Namespace. The other one would be cluster scope. Yeah. So in this instance, this cron tab, for example, is namespace scope. So if you built a cron tab in this single namespace, it's not going to be shown up in another namespace. It's like how we have service accounts and things like that, pods and so on and so forth. Those are all technically behind the scenes namespace scoped. You can do cluster scope things like a namespace, for example. So the demo I have will actually use a cluster scoped resource to do something. I'm not going to tell you what it is yet. You pass in names, so you pass in the plural, singular, and kind. Kind represents what the actual kind looks like in the YAML file. So in this instance, this represents what this represents. And it just looks like a Kubernetes object. Everything looks like this. If you just learn those top 4 keys, spec or data rather. So if you just learn those, your life is going to be so much easier in Kubernetes. YAML doesn't get so difficult at that point. And this is what that actually turns into as a Kubernetes resource. So when you define that custom resource, now you can take this when you define that custom resource definition, you can then create these custom resources. Naming gets really confusing. One of those hard things. So back in here, we have a cron spec and an image that represents or that is being used by it. Does that make sense so far? Cool. So, what can you really do with these things? With just that alone, you can't do much. So you build operators. And operators, as Chris Nova kind of talked to me about it while we were at reInvent, I came to her because I was like, I hate the term operators. It got coined from CoreOS, which we'll talk about on the next slide. But for some reason, for me, the term operator just feels so backwards because Kubernetes is built with controllers. So I struggle with it, even though I've called my own project an operator. But her definition was operators are domain specific. So if you think about the way that the cloud provider plugins work, for example, we have the interface for cloud provider, and then we have implementations of that behind the scenes. That's kind of the relationship that you have with controllers versus operators. A controller would be something like an interface for it, and an operator would be an implementation of that. So, operators, coined by CoreOS, they're a standalone pod in a Kubernetes cluster. They can be multiple, but they don't do much else besides whatever they're meant to do. They follow that control loop pattern, and they watch the Kubernetes API server for updates, using the same APIs that we actually implement in Kubernetes core. So behind the scenes, Kubernetes core is built off of code generation, and we'll talk about that later. And because of Golang not having proper generics, we have to code generate all of the client libraries for this. And so you can define a single file, and then run the code generation, and generate a client, an informer, and a lister, and basically all the pieces you need to actually listen to the API server for that custom resource, and then take and build your own reconciliation loop. So you can watch any Kubernetes resource. It doesn't have to be the ones that you actually implemented. For example, if you wanted to, that cron tab could listen to the nodes as well as just the cron tab resource if you built an operator around that. And it allows you to take action and do updates. So anything you want, you can do with this. You have access to the whole Kubernetes API server as long as you give it RBAC permissions to do that. So a simple use case is that link above. That's the actual GitHub project for it. Don't use this in production. Absolutely do not use this in production. Just don't. It's a terrible idea to use this in production. But I find that it's a decent way to show what you could do with this. So this project is called the Node Operator. I built this a long time ago using a tool called Operator Kit, and recently rebuilt it using the raw Informer libraries because they're a little bit more powerful. It uses client Go and exposes a CRD for managing authorized key files. How many people remember like SSHing into nodes and having to manage authorized key files for every employee that you had? Yeah, did that at a couple startups, and I was like, wow, this is ridiculous. Let's take this into the Kubernetes world. Don't do it, but it works. So you deploy the operator, and when you deploy the operator, you also deploy the CRDs that work with it. And then you have an authorized key resource that's exposed on the API server. And what that does behind the scenes is it rewrites and adds the keys to the authorized key file. Very simple, but it's a decent way to show the implementation. I'm gonna put this down, and hopefully my voice is loud enough. And that's not too loud. Maybe. Cool. So we have a couple things. So on this side, this is basically my current authorized key file on this cluster that I created just for this instance. If I went in and actually said get CRDs or CRD, you'll see that I have two in there. So you can actually list them. So CRDs are listable against your cluster. With EKS, for example, this is an EKS cluster. We have a specific CRD called ENI configs that allow you to add in non-RFC 1918 CIDR ranges into your cluster. But you can ignore that one because the authorized key one is the one that we're actually talking about. And if I did a describe on this, and scrolled up a little bit, you'll see that my definition looks something like, I'll actually just do the single one, which was authorized key. So in here, I have my accepted names for this under the status, but up here I have the actual definition that I wrote, which is the group as node.chrishine.com. I have my names that it's represented as, the scope is cluster, and then I've added in some simple validation in here. So this is just pattern matching. You can do a bunch of different validations. If you're not familiar with the Open API v3 schema, you can look up all of those parameters. We support most of them in CRDs. Things like defaults don't work yet. And that name that I showed you before is somewhere in here. I don't know where it is. And that's about it. So that's a custom resource definition being passed in. Now what I did to make all this happen is I wrote a very, very basic controller. And it looks something like this. How many people are familiar with Go? Cool. All right. So I'm going to try not to go too deep into this then. But basically, we have a main function that I'll show you in slides as well. Maybe I'll skip through it because I'm just going to show you on here. We have a main function in here which takes in some flags, sets up a channel for stopping it, so being able to create a graceful stop on the operator. So if you it won't shut down in the middle of trying to process something. You go through and you build a config for Kubernetes. So this, I'm passing in the master URL and the config file, kubeconfig file, and this is basically initializing the Kubernetes client. And then I go down here to create my node client. And my node client is what I have. It's the code-generated node client that I use, and I create a client set for it, or I use the client set libraries. And what this is really doing is saying, hey, I want to be able to connect into Kubernetes, but specifically look for any of the resources that I've defined under that node type CRD. And then it goes in and it creates an Informer factory, which is getting cut off over here, which is basically saying, I'm going to create this, this piece of code that listens to the API server and resyncs itself, what you can't see is every 30 minutes. So if I haven't gotten any notifications or anything like that. That's going to resync itself every 30 minutes, just to make sure it's always in sync with whatever the API is. And behind the scenes, this is basically an in-memory cache of those resources. And then I initialize my controller, and so this is custom code that I wrote. Everything else that you've seen so far is all code generated. So this controller, I'm passing in my node v1 alpha authorized keys. So that's all, again, code generated. But this controller, what it actually does is it goes and implements a little bit in a complex way, but not. This new function is what we're really looking at. It initializes a new controller struct, and then it comes down to here. And this block is the really important bit. It's saying, with that informer, add some event handlers. For every time there's an add, update, or delete, do something. And in the do something, it's controller.enqueue off key, controller.delete off key, and then for update, I have to do some logic to basically eventually pass it to enqueue off key. Realistically, this is saying, are they the same? If they are, don't do anything. If they aren't, enqueue it. And by enqueue it, we're actually using a really cool and powerful component in Kubernetes called the work queue. And the work queue is an in-memory FIFO queue that you can basically pass just a rostering onto, and then you can pull off of that in another Go routine, for example. So this runs in a single Go routine, and then down below, where I actually do my processing of this, which is my run object, I'm able to loop through those and process every single item that gets added to that queue. So now those are independent processes, and it's highly scalable in that nature. And that processing, what I'm doing is going down into, where is it? There, my sync handler. Going down into the sync handler, which is just grabbing the key that gets passed into it, trying to pull out the namespace versus name out of it. In this instance, because it's cluster scoped, it doesn't actually have that. It's just a common practice to kind of always pass it into that. And it checks to see if it's in that in-memory cache. So that off-key lister is where all of those off keys get stored every single time you get them added to this code. In here, it basically says if it's not found, do something, which is delete. Why I have sync true. Sync true basically means to delete that. And then otherwise, if it does find it, what I want you to do is do this. Initialize a file object and do off key sync with it false because I don't want it to delete the object. And this code right here is what's actually writing it to the file, and that's all this code's really doing. It's really simple, but it kind of proves out the purpose of, hey, I just want to change one thing on the file system every single time. And you can imagine this doing anything. If you wanted to, I know CoreOS started to do this early on, while they started to develop and design the operator pattern in itself, thinking about how to do upgrades of packages, for example. How to do like a yum update or a yum install such and such package when you're just from mutating a CRD, never having to actually get on the node. Basically, don't SSH into nodes like I'm trying to show you how to do here. Just don't do it. So, going into the quick demo of this, what I have is basically I have locally, because I'm running off of a Cloud 9 instance, which is just our IDE in the cloud backed by an EC2 instance. So in here, I have an example off key. I have my public key for my local machine added in here, and then down here, I'm going to try and SSH into one of my nodes using my test RSA key, and it's going to say I can't SSH into it because I have permission denied. And if I go and actually do k apply -f on this example's authorized key, what's going to happen is you'll see over here, because this is just tailing /authorized key on one of the nodes, it added it down here. Really simple. Now if I go back over here just to show, I'm now on the instance. So you can go and do this incredibly fast. You notice how fast it changed it. And if I go and do the exact same thing and do delete, it'll delete it. Now it updated and it doesn't have it anymore. So it's incredibly fast and incredibly powerful. And how I'm actually doing this on the instances is I just deployed a daemon set. My daemon set mounts that file every single time it boots up. So you can imagine you can do this for a lot of different things. Anybody have any good examples that they can think of just by seeing this? Yeah, you're shaking your head. You already used them, so it's not fair.
We use this to do launch Spark jobs. We use this to launch TensorFlow jobs.
Yep.
It's pretty fun.
Yeah. Yeah, those are great use cases. The Spark operator exposes CRDs to create Spark instances. Today on the Kubernetes community call, which by the way, I should say, because of CNCF and all that stuff, join the Kubernetes community calls. They're every Thursday at 10 a.m. It's in, if you haven't seen this, get hooked up. Can't type because I'm in front of people. Kubernetes, /community. If you haven't seen this repo before, this is an awesome repo to go through. If you're just getting into Kubernetes, go check this out because the Kubernetes is incredibly vast and spans across so many different verticals. So, how many people know what SIGs are? Raise your hand. 2. Okay, SIG stands for Special Interest Group. And that's how Kubernetes itself gets together as a group. We also have these things called working groups, WG, in this repo. But in here, we have a ton of SIGs. And those SIGs represent anything from API machinery, which is what writes all of the code generation libraries and what is exposed using CRDs. SIG apps focuses on how to do application development on top of Kubernetes. And they meet at like 9 a.m. on Mondays. SIG architecture has a 7 a.m. meeting on Thursdays. And it's like, you can basically go through any of these folders, go to their readmes, and find out when they meet, read their meeting notes, join their Zoom calls, anything you want. It's all open, but it's pretty exciting because you have this world of new things. For example, tomorrow morning at 9 a.m., there's a SIG AWS call. I don't know when SIG Azure's is. Do you know when SIG Azure's call is? Do you know when, no? Do you know when SIG Azure's call is? No? Okay. Never mind. I won't do that. So you can join any of these meetings and see how Kubernetes is moving forward and see where it's changing. Because every SIG also owns sub-projects. For example, I'm an approver on the AWS IAM Authenticator project, which means I'm allowed to merge pull requests and I'm allowed to review pull requests and do things like that. And we have a very rigid structure because we have so many people working in Kubernetes. And there's so many different pieces moving forward all at any given time. So go through this repo. It also has things about how to actually contribute to Kubernetes if that's something that's interesting to you. Yeah, heavily recommend that. Now, back to this. Or actually, I think I go back to my demo or my slides now. Cool. So I already talked about this because I showed you. Actually, I didn't even show you in real code, and I'm going to skip through my slides because I don't like looking at code in slides. It's not as much fun. But I talked about code generation and how Kubernetes clients are created. It's very, very cool, in my opinion. And I'm going to tell you it's very cool because I like it. So when you actually want to take a CRD and do something with it, you write a types.go file. And here you'll see this path that goes APIs, node, v1, types.go. There's a couple other files. These are basically, these two are boilerplate, and this is code generated. Types.go, what you do is you write out how it would look in Go. So every time I get an authorized key, I'm going to add in these two top level keys, which are Kubernetes specific. So Meta v1 actually is an API machinery package that I'm including. So I showed you the SIG API machinery. They maintain that package, and type meta actually adds in all of the metadata that you have, like the two top keys of API version and kind, for example. Object meta adds in the JSON metadata key. So anytime you have metadata.name, metadata.label, so on and so forth, that's all contained in this object that you don't have to re-implement every single time. Then you define your objects. So in my example over here, my object was a data key, not a spec key. So I have JSON parsing of data, and then this is an authorized key data type, which is represented right here, and it just has the key and a JSON parsing of key. It's really simple. But down at the bottom, we have to define the list version of it. And so anytime I do kubectl get authorized key, it will use this type. And it's basically going to have a type meta, again, and list meta. And list meta just has a couple different keys. It doesn't expose, I think it's labels that are removed from it and a couple other things, as well as like the resource version. And then underneath it, it has items. And items just is exposed as an item key. So it's really, really basic from that perspective. And there's only like these few things that you really need to know. Once you've done that, you get to use all of Kubernetes code generation. I'm just going to show you the shell script that runs it, because it's under k8s.io/code generator. If you go to git.k8s.io/code generator, you can actually go look at this project. Realistically, we end up with a shell script called generate groups. That shell script fires off a couple Go packages, and behind the scenes, this is what I'm passing into it. Deep copy, which was this file. There we go. This file that ZZ generated. This actually says deep copy. If I can get it to move. No, maybe I can't get it to move. That basically says there. Deep copy.go. So this command actually generates that file. Then it generates client and informers, and what you can't see over here is lister. And what those are what I showed you in the controller, but I'll also show you in the file system. So we have client set right here, and we have informers, and we have listers. And all the code underneath here, which is versioned, has fakes so that you can actually do testing on these things, and then has the implementation of those. So an authorized key resource. So what does the getter look like? What does the interface look like? It generates all this stuff for you just based on that types.go. So implementing these things, you really only write maybe 100 lines of code and then code generate everything else, and you have an operator.
Is it using Kubernetes or what is it?
So I'm actually purely using Kubernetes client Go libraries. So I'm not using any frameworks to actually build this. Frameworks that are external at least.
So this code generator is part of which?
Yeah, so it's actually this project. Get.k8s, get.k8s.io/code/generator. Yeah, so it's this. Yep.
Can you write this with other languages or?
You can. So under Kubernetes, what's the SIG for it? I think it's Kubernetes clients. Under this client? Yeah. So under here, there's technically client libraries for all of these things. They don't all have the same things. They don't have the code generation built for every single one of them. The code generation is really meant for the Go packages, but I've worked with, and I have other employees, or not employees, coworkers that have built things with Python and basically use the same libraries just without the informer setup. So you can actually connect directly into the API, listen to the watch API, grab those resources. You have to build your own internal cache, but that's the major difference that you'd have. So yeah, you can use any of these things. They have client libraries for most packages. I don't know the support level on a lot of these things, to be honest, but like Perl is a work in progress. I remember hearing that they added this in the last like 2 weeks, which I think is wild. Let's do Kubernetes with Perl. Anyways, that's how all that stuff works. So it's really rich and allows you to extend Kubernetes in a really nice way. Now going back to slides, because I'm not going to show you any of this stuff, because this is what I just talked about. Types.go, updated, generated, controllers, sync handler, other use cases. So this is where I get more excited because I have real use cases that I actually use all this stuff in. Here are 3. This is my lame logo for my project. Basically, the AWS Service Operator, which I'll show in a second, and it does it. Maybe that didn't work. Okay. So the AWS Service Operator uses the same exact mechanism to build or to deploy AWS services. The etcd operator, that will go and deploy etcd instances into your environment. So if you ran something that needed etcd, this could be maybe like Crossplane, for example. It needs its own etcd instance. Service Catalog needs its own etcd instance. You could use this to create any number of etcd instances for you. the Spark operator will go and actually will create Spark instances for you. Prometheus operator will go deploy Prometheus clusters for you. So a lot of good use cases out of it. I personally like mine. This is my project called the AWS Service Operator. If you want to check it out, it's that, or it's just, oh wait, close out of here. Close out of PowerPoint. There.
Is it on the dashboard yet, or is it planned to be?
What do you mean by on the dashboard?
So you can use it off your standard AWS console?
No, this definitely is not. Also, our dashboard doesn't, or like our console doesn't really have any of the Kubernetes constructs in it. That's something that we right now are looking at it from the perspective of, there's a great dashboard that the community's built. You can deploy it into your cluster. You can use that for that implementation. It does support CRDs, but it doesn't list off everything that you have deployed into your cluster. And what the,
Dashboard doesn't have CRDs.
what's that?
Kubernetes dashboard doesn't have CRDs.
It doesn't? I thought you could actually create your CRDs from it.
There's a long.
All right, never mind. I lied. It doesn't support CRDs. Sorry.
I want it. That's
You
why.
want it? Okay. Did you file an issue yet?
That is an issue
Good.
a year ago.
Here we go. Okay. All right. Well, maybe one day they'll add it. There's supposed to be like a dashboard V2 project supposedly coming out sometime soon, maybe? I don't know. A reinvigoration of the dashboard. I don't personally use that. I like Kubectl so much more. So the demo for the AWS Service Operator looks something like this. I've already deployed this load balancer because it's AWS and it takes like 5 minutes for it to actually provision. I'm not going to make you wait for that. So over here in my second terminal instance, I have a cluster. Get all dash all tab complete, please. There we go. All namespaces. So in here, this looks terrible, but I basically have a deployment with a replica of one called the AWS Service Operator. And then I have a replica set that goes along with it. And then I have somewhere in here defined a service account, which I already have the URL open right here. It doesn't render because nothing's there. And basically, what this actually looked like in the implementation phase is this. So this is the CRD that I've actually exposed. And on my cluster, I can actually go on this side and do get CRDs, just like I did in the other cluster. And in this one, you can see I have CloudFormation templates, DynamoDB, ECR repositories, node groups, Elasticache instances, S3 buckets, SNS subscriptions, SNS topics, and SNS queues. So all of those are actually represented as CRDs. And you'll see on this side, we have service-operator.aws v1 alpha 1. It's an alpha project still. Kind of DynamoDB. I specify the name as the DynamoDB table. And then you have your attributes that go along with it. Behind the scenes, what this is really doing is it's using CloudFormation as a scheduler and saying, create this thing for me, delete this thing for me, update this thing for me. That's what the operator's doing. It's doing that same exact reconciliation loop that we just talked about, but using an external component as my scheduler, so I don't have to implement all of that. Then the rest of the demo is a service, and that service is exposed as a type load balancer, like I said, that's already created. And then I have a deployment, and my deployment uses a very basic application that I wrote called Dynamo app, and it mounts in an environment variable of table name using a config map key ref, and it looks for DynamoDB table. If you're paying attention, you'll notice that Dynamo table is actually the same name as this at the top. But you'll notice that I also haven't defined that DynamoDB config map table at all. Sorry, DynamoDB config map. So what the operator does is it will go and reach out to CloudFormation, provision the resource. Once CloudFormation says create complete, I'll actually go and create a config map locally, and now this will be in a waiting state. Technically it shows an error state right now because this config map hasn't been created. And once the resource comes back complete, it'll create the config map, allowing the pod to boot. So I have like a pseudo dependency tree within Kubernetes and AWS resources. Your question?
So we can create RDS resource as well?
No, not as of today. I've been talking with the team to get a standard CloudFormation template to do it. Should be coming soon. Should be coming soon.
But potential is there.
But yeah, the potential's there. And the project is incredibly simple to extend. I use Kubernetes code generation as well as my own code generation to generate everything. So you write a YAML file that represents CloudFormation and Go, and it's like the intermediary. You run the code generation, then you have it. So if you already have a CloudFormation template for RDS that your organization likes, you could technically extend this and deploy your own instance of it.
So it works only with AWS resources. I mean, if we can make it for people, basically using Terraform.
No. So that's the one thing. And there's good reason for that. The ability to actually use an external resource as a state store as well, and basically have the update and delete and create lifecycle for you pre-built, and not have to maintain like a Terraform apply file, is really beneficial. There's a project out there that technically is starting to look into that exact example. It's a little bit different. It doesn't expose it at the individual resource level like this does. Yeah. So if you actually go and take this, and I clear, and I do k-apply -f on my Dynamo app thing, what I can do is I can do k-get Dynamo -o YAML -w to watch this, and you can see down here under my status, I'm pulling back the status from CloudFormation. So every single time something goes through, an event in CloudFormation, if you're familiar with it, we get this event passed back in, and I'm listening through an SQS queue, and writing that into etcd, so that you never actually have to go to AWS's console. Everything is just there. So a developer could say, hey, I need to model my RDS or my Dynamo when RDS comes. I need to model that because I built a Rails application, and I need an S3 bucket. Model it all here. Status gets pushed back in there. They can k-get whatever the resource is and see its progress. Now to show what it looks like from the pod perspective, it looks like this, which I don't like, and I'm changing my next version of it, but basically it looks like an error. It says create container config error, because it hasn't found that. I have another way that I'm looking to do that by using the init containers and just checking for something instead, because then it will show a ready of 0 and a pending state. So I like that goal later. I just haven't gotten around to it. So now, if I go and list that again, my pod is now running. And if I go get what was it, Dynamo -o YAML, you'll see that this is now create complete, and there's my stack. And if I also do k-get cm for the config maps, you'll see that I have that config map. And in that config map, if I change that to describe, and here, I basically wrote out the ARN of the resource, and my region is there, and my table name is right there. So all that data is now stored in that config map, and anytime you did an update on it, if any of this changed, none of that should change, but if any of it changed, it would update in here.
Is your config map declarative, or did you code generate that?
I code generate that.
Did you?
Yeah. So how this all works from a like code generation perspective, it's in this project, and so in here, how you actually declare these things, it's really simple. This is my model definitions. My model definitions basically go through, and it looks kind of similar to CRDs, where we basically say I want a DynamoDB resource, I have the kind, the type. These pieces are basically saying that I want you to use SQS to get notifications back, because I have custom types that do other things. For example, when you deploy a CloudFormation template, it writes it to S3 so that you can reference it in from these custom resources. Goes through the short names, what the scope is, and then it lists off how the schema looks. And then down at the bottom, I grab the outputs from the CloudFormation template, and I can reference those using Go templates in here. And that just code generates everything for me. Yeah.
Does this assume that your Kubernetes node has the IAM roles?
It does. It does. So that is the one giant security hole.
Yeah.
Giant security hole. Giant security hole, which will get solved. We have a project, it's issue 23 on the AWS containers roadmap, which will solve this eventually. Right now, the IAM to pod strategy is kind of janky, I guess. That's the easiest way to say it. Like, using Kube to IAM is an okay tool. It just has some security flaws that you need to understand. It's just using IP tables to rewrite wherever the instance metadata IP address is going towards. Our long-term solution is in issue 23. in essence, we're going to eventually use service accounts to be able to allocate using like an OIDC backing for those, so that you could say, from this service account, give me these credentials as well. And then within EKS at least, it'll provision that from the control plane side of things and be more secure. So eventually that'll get solved, but right now, yes. This basically needs admin access or access to do every single resource that could be created.
I think there's another add-on which is replacing KIM. I forgot his name.
KIM is another one.
Yeah.
There's also like an IAM controller. There's a bunch of projects that all do this. They all have their gives and takes. Yeah, the fact that you have the instance metadata store that is technically queryable is kind of an issue for that. So going back, I didn't even show you. Now if I go back over here, this renders and it does some JSON. All that code that I did, all that actual container, all it does is it checks for that table name. If it has the table name, it goes and writes a key into DynamoDB. Every time you list or you get the root of it, it pulls the items directly out of DynamoDB. So it's super simple. This key is technically now, if I went into AWS, I went into my dashboard, I could go and look at Dynamo, and I could see that in my tables, I have this Dynamo table that I created, and in that Dynamo table, I have one item called AWS operator, which is the same as that. So that's kind of like a more real world use case. Don't use the SSH key one, just don't do it. It's just a very basic thing. I don't want to show you this code base because it's more complex. So other things that you can do with this, because I'm a little bit over time, storage solutions. If you have something that doesn't fit into the CSI world, this is a really good use case. Go check out that first link that I had in there about awesome operators. It's off of the Operator SDK or Operator Framework GitHub project. That's CoreOS's project. Databases are another huge thing for this. We have a lot of people that are doing different types of databases with this. Again, that's like the Prometheus operator, for example. And then any out-of-cluster tool that you have an API from, you could implement these with. So you could have, like, there's a whole story about Kubernetes managing Kubernetes. People call it the Kubernetes story. I think it's fantastic because I'm too deep in Kubernetes, and so that's what I love. But I think that's a hugely beneficial story. If you could go and do provision VMs with this, or provision anything you wanted with it, new switches in your data center, for example. There's so many things that you could actually implement with this strategy. And that's pretty much my extending Kubernetes. Thanks, everybody. Any questions? I guess it's just yeah.
CRDs versus service broker. How do you?
It's a great question.
Yeah.
So CRDs versus service broker. Service broker is an interesting project that, in my opinion, this is purely my opinion, was shoehorned into Kubernetes. It came out of Cloud Foundry, and the implementation is unlike Kubernetes in that it's not resource focused. So when you deploy to Kubernetes, you deploy a pod. That's a physical unit. When you deploy to service catalog, everything is a service instance. And then the spec underneath it is what differentiates it. And so for me, that makes me struggle because I really appreciate the way that Kubernetes has gone with resource focus. Yeah, that's kind of my thought process. You also are restricted into the broker API, which if you can fit your services into that, that's great. For me, I can't because I want to get the data back from Etsy, or I want to get it back from CloudFormation. I want to do a bunch of mutating of those things. I want to have an admission controller that does other things and write OPA policies. Oh, I guess you can technically do that with. It's just a little bit different. Any other questions? Cool. Now go build operators.
Thanks a lot, Chris. Special thanks to both of you for coming from far away. You're coming all the way from San Jose, and Ramesh came all the way from San Francisco, taking out time from their busy schedules on a weekday. So really, really thankful for that.